Hello, everybody. We're going to talk about section 3.4 today, which is about graphing equations in standard form. So we've already talked about graphing equations in slope-intercept form. That was something you're familiar from last year. But now what we're going to do is we're going to talk about standard form. This is going to be our second lesson on standard form because our first one was on story problems, and now we're going to go on to graphing. So we have a little bit of a warm-up problem right here. So I'd love it if you gave that a try. All right, so what you're has to do right here is it says draw a line that crosses the x-axis and the y-axis. And so it can be any line that you would like. So I'm going to create my line so it looks like this right here. The points that I've created that are on the axis, I have this point right here, which is going to be 0, 2, and then I have another point that is going to be right here, and that is going to be -5, 0. Both of these points are considered intercepts. This is called the y-intercept because it crosses the y-axis. This is called the x-intercept because it crosses the x-intercept or x-axis. Okay, so then let's see if we can bring these two ideas together. So I've already mentioned standard form and I've already mentioned intercepts, so let's bring them all together. So to begin with, standard form is actually this form right here, ax plus by equals c. Standard form is different from our slope-intercept form and any other forms that we might look at because it lacks some of the meaning that the other forms have. If you have a form like slope-intercept form, then you know that m right here stands for slope, and that's something that you can bring to the graph. And b right here is going to stand for the y-intercept, which is also something that you can bring to the graph. When we are looking at standard form with its a's and its b's and its c's, these are all constants, so they will be numbers, but they're not going to represent the rise or the run or the x-intercept or the y-intercept the same way that these guys originally did in slope-intercept form. They are numbers, they have value, but it is a little bit more secretive. It's a little bit more cryptic. The other things we have is the x and y, and they're going to be variables. Notice that they're both on the same side of the equal sign. So how do we get the information from here? So from here, what we're going to need to do is we're going to need to see if we can create some x and y intercepts, and that's very easy to do. One of the things that I'd like you to notice is that from the two intercepts that we've already created, intercepts always involve the number 0. And so I want to use both of those ideas right here. So thing number one, an intercept is going to be a point where your graph crosses an axis. It could be on the x-axis, like this point right here, or on the y-axis, like this one right here, but it will be on an axis. And the other important point, and this is going to be point number 2, it is going to utilize the value of 0. 0 is very strong and powerful. It's easy to work with, and it's easy to graph. So that will work out really, really nicely. Okay, so here's our process right here. This is the 4-step process that I want you to try to follow when you're working on these problems. And if you stick with it, you're going to be great. If you want to deviate from the process, you're welcome to do that as well. But I'm just going to try to give you the most straightforward technique that I can right off the bat. So first part, step number 1, we are going to find the y-intercept. And we are going to find the y-intercept by making 0 equal, or 0, x equal to 0. So we're going to set x equal to 0. That's going to be our first move. Then step number 2, we're going to find the x-intercept. And we're going to find the x-intercept by setting the y value equal to 0. Once again, 0 is a really easy number to work with. So when you start plugging in 0 in this spot or in this spot, it is going to be very easy to do. You probably won't even need a calculator. Then step number 3. Step number 3, once you have these guys, you're going to create some points. Our first point that we're going to create right here is going to be 0, some number. And the second one is going to be some number, 0. And these points are things that you can graph. And so that's going to be our job for number 3. We're going to plot the points. So these points are our intercepts. So we're going to plot our intercept points. And then step number 4 is going to be to draw the line. Remember that all of our graphs that we're looking at right now are linear graphs, so they should be nice straight lines. There's no such thing as a curved line or a round line. They're all going to be straight. Okay, let's try it out with our first example and our most important example for the day, and that's going to be this one right here. Graph 2x plus 3y equals 12. So step number 1, once again, is to find the y-intercept. We're going to rewrite this equation, except we're going to put a 0 in it, and we're going to put a 0 in the x spot. You can see a hint for that right over here with my table. I'm going to make a small table that only has 2 points in it, and each of these points is going to be an intercept. And you'll notice that my first point is going to have that x value of 0. So I'm going to have my 2. And I'm going to have my spot for my x, and I'm going to have my 3y and my equals to 12. I'm going to leave pretty much the entire thing the same. The only thing I'm going to do differently is I'm going to put the 0 in there. Okay, so now what do you do with the 0 in there? 2 times 0 is 0, so that whole term basically goes away, and we're left with just 3y equals 12. Then we're going to divide by 3 on both sides, and when you divide by 3, you get a very nice y value. Your y value is going to be 4. Now that 4 is not a number all by itself. It goes with the 0, so the point is now 0, 4. Let's do the same type of thing, except we're going to find the x-intercept this time, and that means we're going to be plugging our 0 in for our y position. This is a little different from what we usually do for slope-intercept form. A lot of times when you're talking about graphing an equation or making a table, what you're going to do is you're going to choose your own x values, which is exactly what we did in our first move. But this time, and only for standard form, you also kind of get to choose your own y values, which is a bit unique and special, and it works out really, really nicely, but it is a bit unique. So that's something to watch out for. So there's my 0 right there in the y position this time, just like it's in the y position in my table. And just like last time, 3 times 0 is 0, and that's not really going to do very much for you. So you're going to be left with your 2x and your equal sign and your 12, and you just need to solve this. And you're going to do that by dividing by 2 on both sides. This is one of those types of things that kids see, and they understand it very easily right off the bat. And because they understand it, they don't spend very much time on it. And then when they get to a checkpoint or they get to a test, they forget. And the reason that they forget is because they never practiced it enough times. So I'm not trying to show you something that is special or fancy right now. I'm just trying to have you practice it enough times so that you can nail it down every time that you see a problem like this for the rest of your life. So there you go. I've plotted my 2 points. One of those points was 0, 4, which you can see right here. And the other one is 6, 0, which you can see right here. And then I've drawn my line that's going to connect the two. And once again, it is a nice, straight, linear line. All right, it's your turn. There's 2 you try it problems, and I'd like you to try those out for me now. Here are a couple of values for our u-try problem. So our first one right here is going to have an y-intercept at 0, 4 and an x-intercept at 2, 0. You can see the 2 points, 0, 4 and 2, 0 right here, and a nice straight line going down through them. This line has got that negative slope. It's running downhill. Second one is going to have a y-intercept at 5. Excuse me, and an x-intercept at -3, which is right down here. This one is going to have a more positive slope, and it is running uphill. All right, let's transition over to the backside now. So on the backside, what we have right here is a couple of story problems. These are very similar to the last round of story problems that we saw before, and so hopefully you feel comfortable with them. And if not, hopefully you're starting to build some of that confidence with them. So this one's about Minnie Mouse and Daisy Duck. Minnie Mouse and Daisy Duck make and sell decorative hair bows at Minnie's Boutique. They sell small bows for $3 and they sell large bows for $5. Each day, the boutique must bring in a revenue of $60 or landlord Mickey will evict the girls. The situation can be modeled by the equation 3x plus 5y equals 60. And this is where the meaning for standard form really comes into play. When I was talking about standard form earlier, and I had shown you the way that the form looks, I had mentioned that there was no slope or y-intercept in here, and there wasn't a lot that you could just bring to the graph. But when you're talking about a story, there is a lot that you can bring. The reason that this 3 is here is because that's the price of a small bow. And you could sell a lot of small bows or maybe not that many small bows, and so you need a variable. The reason the 5 is here is because that's going to be the price of a large bow, and you could sell a lot or a few large bows, and so you have a variable with it. And the goal here is to make $60 so that they can pay rent to Mickey so that they don't lose their business. And so that is your equation right there, and all those things make perfect sense. But we also must get it onto the graph. So let's do that. The easiest way to do this is to make a table. I know for some people that sounds counterintuitive. Easy and table don't necessarily always go together, but in this case, it's definitely the truth. We want to make a table and we want to use 0 2 times. So the first time I want to plug it into the x position. So that's going to be 3 times 0. And our 5y and our 60 is going to stay the same. 5y and 60 are going to survive, but 3 times 0 is just 0. And then we're going to do some dividing, and we end up with a y value. 60 divided by 5 is going to give us 12. 12 is going to be our first intercept, our y-intercept. Then we're going to do this whole thing all over again, except this time we are going to plug the 0 in for y. And so that is now going to be 5 times 0. The 3y and the 60 stay the same as they were before. Okay, 5y is going to go away, and we're left with our 3x and our 60. And this time, once again, we're going to do some dividing. 60 divided by 3 this time is going to be 20. All right, so let's graph it. So when we graph it, we're going to go 0 units over and 12 units up. Remember, x is side to side and y is up and down. So that is going to be the point right here. And then the second one is 20 units over and 0 units up, which is going to be right over here. All of these graphs should be linear, which means they need to be connected with a nice straight line. These are 2 easy points to work with, but they're not the only 2 points. The other points live on the line, and so it's important that you include that line in between them. Don't just plot the points and be done with the problem. All right, so next part right here. Give 3 possibilities for the number of each type of bow that Minnie can sell in order to earn the $60 revenue. That's our goal. Our goal is to make $60. So now we've already come up with 2 of those situations. If Minnie and Daisy did not sell any small bows, but they sold 12 large bows in a day, they would make their $60. Similar to that, but opposite, if they sold 20 small bows, but no large bows, they could make their $60 that way as well. But realistically, what's more likely to happen is that they're going to sell some small bows and some large bows. It will be a combination of the 2, not just one kind or the other. That is a little bit unrealistic. So then the question becomes, well, what are some combinations of small bows and large bows that you can sell? If you look at the graph right here, you'll notice that if you just pick a point at random, most of the time it's probably going to be some sort of decimal value. And so those ones won't make as much sense for the story because you can't sell part of a bow. It doesn't really work very well. So if you're looking for some nice clean values, some ones that will make you your $60 without having to split bows or anything like that, here are a couple of options. If you sell 5 small bows, and then what you could do is you could sell 9 large bows. 9 large bows would get that job taken care of. And we can see that very quickly and easily. That would be 3 times 5, and that would be 5 times 9. If you do 3 times 5, that's going to be 15, and 5 times 9 is 45, and 15 plus 45 is going to give you 60, so that works out just fine. Another combination that will work out well is the combination of 10 and 6. If you sell 10 small bows and 6 large bows. And once again, if you do 3 times 10, and then we would do 5 times 6. 3 times 10 is $30, and then 5 times 6 is another $30, and that is going to give you a grand total of $60. So that one's a really good one as well. Then another final one that I could add to this list is 15 small bows and 3 large bows. If we do 15 and 3, 15 is going to get multiplied by 3. And then 5 times 3. 15 times 3 is $45. And not surprising, you can see that the 45 shows up here, and it also showed up here. And then 5 times 3 is 15. And once again, the 15's back again. And that's still going to give you $60 in total. So those are 3 good combinations right there. Now, if you're thinking more realistically, you're thinking to yourself, well, Mr. Slomka, you could sell 20 small bows and 20 large bows and make extra money. Absolutely, yes, you can. But in this situation, we're just trying to see if we can break even. So we have an equation that is equal to 60. So we're trying to hit that mark directly head on. So this process is very straightforward and simple. I want you to try to see if you can practice it one more time with this antique cell phone policy that I used to have to follow very carefully when I was a student at Michigan State. Here's our setup right here. So my equation right here, I need to make sure that I only spend $5, and each text message that is sent costs 2 cents, and then each text message that is received costs 7 cents. This is a devious plan right here. Making the sending text messages cheaper is really good because then it will make it seem like it's a good idea to send out lots of text messages because it's very cost effective. But remember that 9 times out of 10, if you send a message, you're going to receive one as well. So what you had to kind of do is you really kind of had to think about each text message as being 9 cents, if not more. So there's our setup right there. My table, I can make a table very quickly and easily if I use my intercepts. My first one being my y-intercept that you can see right here, right below the 75. And then my second one is going to be my x-intercept, which you can see right here as exactly at 250. For my first one, what I have right here is both of these situations are pretty wild and crazy. So in our first one right here, we have 0, 71.43. So right off the bat, it's 0.43, which you can't send 0.3 of a text message. That doesn't make any sense. But if we go on past that, then basically what's happened is we've spent our $5 exactly. And the way that we've sent it is by receiving 71.43 messages. So that means 71.43 times somebody sent you a text message, and then that was it. You never responded to them. You said nothing out, which is a bit of a toxic and strange relationship. Second one, in this case right here, you send out 250 messages and you spend your $5 that way, and not a single one of your friends or acquaintances or relatives ever messages you back. So that means you only send out messages and nothing comes back. In a much, much more healthy situation, you send a couple text messages and the people around you send them back as well. So we can see that the pink line right here is where the healthy portions of the relationship are going to be. And it is these extremes over here and over here where we've got ourselves a problem. That's not so good. As far as combinations, this one's a lot easier than the mini boutique one. You really can't go wrong. Any type of value that you pick for either your sending or your receiving is going to match up really nicely. There's not that many decimals. In fact, this is only one of the ones. Basically, every other value that you have is going to work out really, really nicely. So you can see a whole bunch of them that I've picked out right here that all work out really great, and there's no issue whatsoever with them. And you can pick whatever ones you want, whatever ones make you happy. You just have to choose 3 other possibilities. Okay, that is all of the notes that we're going to be going over today. And now what I need you to do is work on your 3-4 practice.